Okay, today we're going to do section 4.6, Solution Stoichiometry. And solution stoichiometry is used to solve stoichiometry problems that involve molarity. And the way this is worded is using stoichiometry to solve problems involving molarity. There's 3 hints that you're going to get. When you're doing these problems, whenever you see molarity and a reaction or something about a reaction, you know that you're doing solution stoichiometry. Now, if you're given molarity and volume of a chemical, you have to use these to solve for moles, and then you use stoichiometry. So anytime you're given molarity and volume, you use these to solve for moles, then you use stoichiometry, and in this, you always start your ladder with the volume. Always start the ladder with volume. Okay. The next thing. If you see molar in a problem, cross out the capital M and replace it with moles per liter. And the last one you're going to get, and then we're going to start solving some problems, is if a problem asks for molarity, you will use stoichiometry to find moles. Use the reaction to find moles. And then you're going to divide the moles that you find by the given volume to get molarity of the unknown. So let's do a problem. What volume of 0.2 molar NaOH is required to react completely with 25 milliliters of a 0.3 molar phosphoric acid solution? Let's put a square around volume because that's what we're trying to find. And we'll circle everything that we're given in this problem. Notice I'm given a volume and a molarity, and by number 1, if you're given molarity and volume, we're going to use these to solve for moles and then use stoichiometry. And we always start the ladder with volume if we're given molarity and volume. Okay. So we're going to start with volume, 25 milliliters. We need to convert this to liters. We move the decimal 1, 2, 3 places to the left, 0.025 liters. Now, another hint in this problem solving, if you see molar, cross out the M, replace it with moles per liter. So I'm going to put a little slash through here in a different color, moles on top, liters on the bottom. So I've replaced my molarity with moles over liters. Oh, there's another one over here. I'm going to replace this one also with moles over liters. Now notice this molarity right here has liters on the bottom. I can put my liters on the bottom to cross-cancel. Moles on top. I'm using molarity as a conversion factor. We are allowed to do that. So it's 0.300 moles per liter. 0.3 moles per liter, that means per 1 liter. Whenever I say per liter, it's per 1 liter. Now I have a problem. I don't even have a reaction. I need to go from one chemical to another. I need a chemical reaction. You need to figure out how to balance H3PO4 with NaOH. Now, we're not going to spend the time doing this right now. I'm just going to tell you real quick. I'm switching my cations. Phosphate is -3, sodium's +1, so I need Na3PO4. And I'm also going to have HOH, but I want to erase this arrow because it's going to get in the way here. So I need my reaction. It's going to end up being 3 HOHs because I have to balance it. On a test or a quiz, you might have to predict the whole reaction and then solve it. Sometimes the reaction will be given to you. So I just predicted my products. Now let's go back to the problem. We need moles, phosphoric acid on the bottom. And let's see, we're trying to get to a different kind of mole. We're trying to get to NaOH. So I need moles of NaOH on top. Moles to moles, moles to moles, use the reaction coefficients. So here, I look at the NaOH, and I need a 3. I look at the phosphoric acid, and I need a 1. Okay, we're doing well so far. Question asked for volume. So I'm only at moles right now. I need to get all the way to volume, so I need moles NaOH on the bottom. Do you see something in the problem that get me from moles to liters for NaOH? I see something. It's right here. Molarity. I can use it as a conversion factor. It's just liters. We don't write liters of NaOH. So it is 1 liter and 0.200 moles. That's because the molarity is 0.200 moles NaOH per liter. That means per 1 liter. So let's solve this. Okay, I get 0.1125 liters, but now I have to check sig figs. So I'm going to use purple just to highlight the sig figs. I've got 0.200, 3 sig figs, 3 sig figs, 3 sig figs. Looks like I need to keep 3 sig figs right here. I need to round 0.113 liters or 11.3 milliliters. Sorry, not quite right. Hold on. 113 milliliters. There we go. Either of those are correct. Now we're going to go on to the next problem. Okay, what is the concentration of a calcium chloride solution if 50 milliliters, that's a given quantity, I'm going to circle that. I'm going to put a square around concentration because that's what I'm trying to find, are needed to completely precipitate out the silver ions in 25 milliliters of a 0.5 molar silver nitrate AgNO3 solution. Okay, so I've got a volume here, and I've got a volume and molarity. Oh, I remember something. This right here, if I'm given molarity and volume, then I can... All right, so we are going to use volume and molarity to solve for moles, and then we're going to use stoichiometry, and we're going to start the ladder with volume. So let's go back. Oh, and we need a reaction. So let's first do what we were talking about. We're going to start with our volume, 25 milliliters, which is 0.025 liters. Start our ladder. We will use molarity to do our conversion. Oh, that's the only molarity in here that we can convert into moles over liters. So we know we need 0.500 moles AgNO3 per 1 liter. Now we need our reaction. So our reaction is calcium chloride plus silver nitrate. Don't worry if you're not as quick as I am at this. The focus here is not on predicting products, because we learned that already, but it's something you might have to do in a problem. So calcium's plus 2, nitrate's -1. That's why I put the 2 subscript on the nitrate. And then I have AgCl. I do not carry over the 2 on the Cl because I never carry over subscripts. Ag is +1, Cl is -1, so that formula is good. And now I've got to balance. I need a 2 here and a 2 here. Okay, so I'm now ready to convert to a new chemical. I've got my silver nitrate, and I'm going to convert that. What are we looking for? We are looking for the concentration of calcium chloride. Always read your question to find out what chemical you're going to. Moles of calcium chloride. And let's see, 1 mole of calcium chloride to 2 moles of, oops, wrong one, 2 moles, but same number luckily, 2 moles of silver nitrate. Okay, let's look back here. This third step. Wait, were we asked for molarity? Yes, we were. In this problem, we're asked what is the concentration. So we need to find the molarity. We use stoichiometry to find moles, and then we're going to divide the moles by the given volume to get molarity. So I'm going to get my moles. Okay, I solve for my moles. Now really I should only keep 2 sig figs here. I'm going to keep 3 until the very end. It's okay to round here, but you can round at the very end. I divide by the volume of the solution I'm looking for, this volume right here. I need liters, 0.050 liters. And we get 0.125 molar. Moles per liter is molar. And with sig figs, it's 0.13 molar. All right, let's move on to the next question. Got some funny little red dots in there, which we're just going to ignore for now. Okay, what volume of, this is a given quantity, 0.2 molar AgNO3 will be needed, oops, this is what we're looking for, volume, to react completely with, this is the other quantity we're given, 31.75 grams copper according to the reaction given here. So let's see. I'm given a mass and I'm given a molarity, and I always want to cross out molarity and write moles per liter. I don't have a volume. There's no volume yet associated with this molarity. So I cannot start a ladder with volume, and I can never start a ladder with molarity because there's nowhere to go with that. So I'm going to have to start with my copper. 31.75 grams of copper. We need the molar mass of copper, grams to moles, use molar mass, grams of copper to moles of copper. Moles to moles, use the reaction coefficients. Moles of copper, where am I going? I'm trying to find silver nitrate. Moles of silver nitrate, okay. Let's see, 1 copper and 2 silver nitrates. Now, it would be moles to grams, use molar mass again, but I can't do that. I've got molarity here, and I'm trying to find volume. Do you see that this right here, the molarity, I can use as a conversion factor? It's 0.200 moles of silver nitrate per liter. Per liter. I'm allowed to have a molarity upside down and use it as a conversion factor. Okay, and we get 4.996, and if you look at our numbers, we've got 3 sig figs and 4 sig figs, so I need to keep only 3 sig figs. The answer is 5 liters. Last problem. By the way, if you want to pause, you can always pause and try to solve this on your own, or just follow along as I solve it. Okay, so pause now if you want to solve this on your own. What mass of copper is needed to react completely with, we've got a volume and a molarity, and molarity, I always cancel it out and write moles over liters. Whenever I have volume and molarity, I start my ladder with the volume, 250 milliliters, which is 0.250 liters. All right, now I use my molarity to convert to moles. So I have 0.100 moles AgNO3 to 1 liter. I'm using my molarity as a conversion factor. And now I've got to get from moles of one chemical to moles of another. I'm using the reaction in number 3. Okay, sorry about that. So we're using the reaction in number 3. We have moles AgNO3 on the bottom, and we're trying to get to copper. We can't go to mass yet. Hopefully you know mass means grams. Moles of copper, let's look. We need 2 AgNO3s, 1 copper. 2 AgNO3, 1 copper. Now moles to grams, we're trying to get mass, grams. Moles to grams, use molar mass again. And that's how we do stoichiometry. Okay, we solved that, and there we go. Okay, I do want to go over, that's all the problem solving, and I want to go over some terminology because there are some special little new terms in this section that you need to be familiar with. Okay, bunch of terms, new terms, and actually the 2 or 3 of the 4 problems we just did could be called titrations. A titration is an experiment where a solution's concentration is determined with another solution with a known concentration. Sometimes it's determined with a solid, actually, as well. An equivalence point is the point where a reaction has just reached completion. So all these problems, what we have solved for in all those 4 problems we just did were equivalence points, where the reaction just got completed. Now when you do a titration, an endpoint is when a color change occurs. And we will do some titrations in class, so you'll get to see this happen. And this is important. You want the equivalence point and the end point to be the same. Last thing, an indicator. That's a chemical that changes color. It's what indicates that you've reached the end point. And there are many, many indicators. The most common type of titration that we do is an acid-base titration. So in some of the books problems, they'll talk about neutralization. A neutralization reaction is a titration. I'm sorry, a titration is a neutralization reaction. The first problem we did in this video, that was a neutralization reaction, an acid-base reaction. Okay, and that's it.